Hi everyone and welcome to this new video. In this video I continue my BSCP guide, and in this video I want to talk about insecure deserialization. So in this video we'll talk about what is serialization, why deserialization can be a dangerous process, and then I will showcase the solution to 3 different Porswigger labs. As always, I hope this video is useful. If you find it so, leave some feedback in the comments, subscribe to the channel, share this video and this channel with like-minded people, and there's also a Patreon for those of you who wish to support me. Thank you very much and enjoy the video. So let's talk about serialization. What is serialization? So serialization is the process by which an object with a complex structure is transformed into a linear format that can be easily saved, transmitted, or stored into the disk. So what's the idea here? Well, the idea is that when we are dealing with computer processes, we are dealing with complex data structures. So when our process executes, it's going to be loaded in the memory of the computer, right? In the RAM memory of the computer. And within this RAM memory, there's going to be a space that is allocated for the process. So the process has this kind of memory available, and within this memory is going to save all the data structure that the process needs to use to execute. So that's the idea. However, in computer science, the same information can be encoded in many different ways, in many different formats. And the encoding of a data structure in memory for execution is not really an efficient encoding when it comes to storing that data into a disk, or, for example, when it comes to sending that data through a network. That is, we need different formats. And so we have the concept of serialization. You can see it in this image taken from the Porswigger Web Academy. So here's the reference, and you should check out this explanation because it's good. So basically we have an object, and this object, we want to serialize the object, which could be a complex object within a programming language, into a stream of bytes. And the useful aspect of doing this is that now that we have this stream of bytes, we can easily save those into a file, use them in memory, send them to the database, and then once we have sent those bytes, we can deserialize in order to obtain the object. I mean, as far as memory is concerned, the object itself resides in the normal RAM, in the normal memory. So we want to serialize to make it more efficient to transmit or save to disk. For example, a useful aspect of serialization is seen within artificial intelligence and machine learning. After you train a model, you obtain certain parameters, and so you can represent those parameters within a data structure. Now, the key aspect, of course, is that you want to serialize those parameters. You want to write those parameters into the disk for achieving persistence, so that you don't lose the parameters if you stop the execution. Now, to get familiar with the concept of serialization, let's consider Pickle, which is a very common serialization library found in Python. Now, this library is not at all secure, and we will see shortly why, but first let's analyze how it works. So here we have a Python code, we are importing the Pickle library, we are defining a simple dictionary structure with some properties and a list of hobbies, and then we have the two operations. We have the pickle.dumps, which takes in a data structure and returns a series of bytes, so raw bytes, and then we have the pickle loads, which does the opposite. It starts from a sequence of bytes and it constructs an object. So basically these are the two operations: serialization, that goes from the data structure to the sequence of bytes, and deserialization, which does the opposite, goes from the sequence of bytes to the complex object. And when we execute this code, we obtain this as the serialized data, and this as the deserialized data. So basically, serializing means encoding this structure into a format that can be easily saved into the disk or sent through the network. And as you can see here we have a bunch of bytes, right? Like /x800495, then there is a G, then there is a 00000000. So we have a lot of stuff that we would not see in the data structure in the typical programming language. However, if we have to save this data structure to the disk so that later it can be restored, we need to put all these bytes as well, all these structure bytes, let's say. And so that's the basic idea. We can serialize objects and we can deserialize objects. And you can play around with this code. It is available on the Patreon subscription. All this content is in the Git of the project. Now, the real question though is why is deserializing a dangerous process? Because there is a vulnerability called insecure deserialization. So we need to ask, okay, serializing is the act of transforming a data structure into a sequence of bytes. Why is deserializing dangerous? Because the idea is that many serialization libraries, many serialization standards allow you to represent not just data, but also dynamic code. That is, during deserialization, the deserializer, the process responsible for reading the byte, interpreting them, and creating the final object, which effectively it is an interpreter because it's reading data and it's executing some action to perform something. In this case, the action is to construct an object, and so the output of this execution is the final object. Well, during this construction, the interpreter, the deserializer interpreter, can read the deserialized data and can execute code based on that data. So it can execute code that depends on the data being deserialized. Once again, let's consider Pickle in Python, which is a very common example. Now, when you go to the website of Pickle, like if you just go here, I think I have it here, yes. I have it here. If you go here, there is a big warning. It says, the Pickle module is not secure. Only unpickled data you trust. It is possible to construct malicious pickled data which will execute arbitrary code during unpickling. So that's pretty much the idea. And they also tell you, which is an important thing, it's a thing that will come back, consider signing data with HMAC if you need to ensure that it has not been tampered with. And then it suggests to use safer serialization formats such as JSON. So a lot of useful information. So why is deserializing with Pickle dangerous? Why is there a big warning? Well, consider this class. This class has been called malicious for a reason. So this class is a single method called reduce, so underscore underscore reduce underscore underscore, and this returns a tuple made of two elements, os.system and then touch act. Like here we have a string touch act. Now when we serialize this, basically what do we have? Well, we have this class, so we can use the pickle.dumps to serialize this class into a sequence of bytes, of serialized bytes. And in this example, we're gonna execute this and we're gonna write everything to the payload.bin file. And here with orgbubble, I can actually do it dynamically. So I just press Ctrl+C, Ctrl+C, I execute this code, and it says serialize payload written to payload.bin. Then I can actually read the payload from the file system, and I can do xdump-c payload.bin. And look at this, here I get these bytes. So these bytes represent the serialized data. And as you can see in these bytes, we find the strings like system, touch, hacked, like this payload would simply create a file called hacked within the current directory. So that's the idea. And by the way, we can see that it has been created in this directory. Now there is this payload.bin, and if you execute it, we obtain the same thing. Like what I'm doing in this org file is just executing commands at the level of the operating system. So in this case, it's reading these files from the file system, from the current directory of the file system. Now the problem is this. It's not when we serialize data that's problematic. It is when we deserialize data that we do not trust. So when we deserialize arbitrary user data, input data. Consider this code. Now here we have no clue about the malicious class. Consider that this payload.bin was obtained through user input. So it is an unknown client of our application that gave us this file. And what we're doing is that we're just reading the bytes and we are loading the bytes. We are deserializing the bytes. Now, if we execute this, like look at this, I'm gonna open the shell here. Notice that I have no hacked file, right? Now I'm gonna execute this. I have executed this code block into the system. And now, if I do ls here, notice the creation of this hacked file. So there is a new file, and we can also see with ls. Look at this. It was created 11:23, so a few minutes ago. So basically, we achieve code execution of the system by deserializing arbitrary data. Now, in this case, of course, it's a simple touch hacked, but you can put into this class whatever payload you want, whatever command you want, and this is gonna get executed also. So basically, why is deserialization a dangerous process? Because many deserializers in the different languages allow you to execute data while deserializing code, while deserializing the data. And this code that is being executed depends on the data being deserialized. So basically, an attacker can choose what kind of code to execute. We achieve code execution, and typically this is done remote code execution through a deserialization process. So very, very dangerous. Now, in this case I showed Pickle, but the truth is that many different languages offer serialization and deserialization standards that allow for code execution. There's also in PHP, there's also in Java, and so on and so forth. It is not really like there's no general serialization routine, it's more like your specific language, what kind of serialization routine does it use? And this serialization routine, is it dangerous? Meaning, can arbitrary code be executed from this process? So that's the idea. Because for example, a very common serialization format is JSON, and JSON is pretty safe. And to be honest, I would say sometimes you should just use JSON unless you really need something more fancy. But if you can get away with JSON, you should probably get away with JSON because it is intrinsically more safe to deserialize. It is a simpler format, there's no code execution, and so on and so forth. So to continue with the video, I will showcase now 3 different laboratories taken from the Portswigger Web Academy to hit the point on why deserializing data is dangerous and what you can do as a web developer, as someone who wants to defend better against this kind of vulnerability. So let's start with the first lab, which is also the simplest. So let's open this. So let's go here and let's just start the lab, basically. So this lab, here we have the description. It says this lab uses a serialization-based session mechanism and is vulnerable to a privilege escalation as a result. So we can log in with the credential winner Peter to get access to a user session, and we need to edit the serialized object in the session cookie to exploit this vulnerability. So basically in the session cookie, we have a serialized data structure and we need to edit it. So the lab has been activated. Here, as always, I have my burp with the proxy. So here I can get the traffic, perfect. So this is a simple shop, but what is interesting to us, of course, is the account page. And we want to log in because we want to establish a session with a website. So we say winner Peter, and here we have logged in. We have the post login, look at this. This post login gives us the session cookie. So, by the way, what was the final objective of this thing? I believe it was to delete, let's see, Chromium, delete the user colors. So we have to achieve admin privileges and we have to delete this poor user Carlos. I don't know why they don't like Carlos, but that's the idea. So let's go into my account. So here we have the my account request. So look at this. Here we have this my account request. And here we have this session cookie. Now this session cookie, if we analyze with the inspector, we can see, okay, look at this. This is URL encoding. Let's also apply like base. Actually, no, let's do URL. But let's also add, I think, let's see. Okay, here I have to select everything. If I select everything, here I can see the final text after it has been URL decoded and after it has been base64 decoded. Now, if you look at this, this thing, what is this thing? What is this output? Like if you just have to analyze this. Well, basically, this output is a data structure in PHP that was serialized. So this is a typical PHP serialization format. How can we read this format? Well, basically here we have this O, which stands for like object, I believe. Then here we have a number, and this number is 4. And this number is 4 because the name of the object, which is called user, has 4 different characters. So here I believe it is the length of the next string. And you see all these elements are divided by these colons. Then here we have a 2, which to be honest, I don't know exactly what it means. But basically here we have the object itself. And you know, even though you don't know exactly what it means, to figure it out, of course, you need to look at the PHP documentation. You can also ask ChatGPT, and probably for this kind of question, it's like any LLM should suffice. Powerful enough, because this is a documentation based thingy. But basically inside the object here we have a bunch of properties. And here we have, for example, S, which is a string, so it is a type. Then we have the length of the string, and we have the string itself. So we have username, winner, admin, 0. So here we are encoding the name of the attributes and the values of the attributes together, basically. And here we have the semicolon that separate the different fields. Now, what is of interest here is that, okay, the username is winner, but notice also that we have an attribute called admin, and here it has a value b. Maybe stands for boolean, could be, and it has a value of 0. So typically, if we have a way to implement admin privileges as a switch on or off, this could be saying the user winner is not admin because it has admin 0. So to make it admin, let's put it admin 1, right? Let's edit this serialized data. Now, if you're able to do that, what could happen is that then the application will deserialize this. It will create a PHP object, and this PHP object is gonna have admin equal to 1. So if in the code later on we have if user.admin something, since we have modified this data maliciously, we're going to be able to overcome this kind of gates, this kind of security checks. So let's try to make sure that this is the case. So how do we do that? Well, if we just change admin to like this, and we just to apply changes, and then we send another request, notice that now if we render it, we see something new. We see this admin panel. So this is new, meaning that we did not have access to that before. Now, if we check the HTML to understand how we can access this admin panel, here we say /admin, so it says /admin. So we go into /admin like this, get /admin. It's gonna say okay, and look at this. Here I have the dashboard to delete the user Carlos. So at this point we just have to check on the HTML how can we actually access that functionality, and look at this. The functionality is admin/delete, and then username uguale Carlos. So we do this, it's gonna say found, I follow the redirection, and notice that I've solved the lab because I have deleted the user Carlos. And this was possible because we were able to edit the serialization cookie. There was no integrity check, and so basically that was the victory. And here I can just remove all unnecessary headers like this, just leave this stuff. Perfect. So I'm gonna copy this, I'm gonna put it into the readme solution. So basically, let's see. So the serialized object used to track session, request to win. Perfect. So I have it already, so there's no need to put it again. So basically, we can just edit this serialization data. Now, how would we fix this? So there are two possible ways that I can suggest you to fix this. The first thing is to add an integrity check. So remember in the Pickle documentation, it said to use the HMAC function. And HMAC is an authentication message function that allows you to sort of like add integrity on the message. And to add integrity means that now, if someone maliciously edits the session cookie, changing the value of the session cookie, the server will know. The server will know that something has been maliciously tampered with, and it's gonna stop execution. So pretty simple. So you need to add integrity to those values that you send to the client that are deserialized. So to not allow the client to just modify them and send them back. This is really important. Another fix in this case though would be, why are you using a deserialized object as a session cookie? So this is another thing. You should just use a random value as a session cookie, a long enough random value. And then if you want to assign to that user session a specific data structure, you can do so in the backend. The user does not have to know the data structure associated with this session. It just has to have the session cookie, which acts like a ticket, so that every time the request has that particular ticket, the backend knows which are the session data to work with. So like, why send it to the user? So in this case, I would just change the entire design of the application, because to me, it feels like it is an insecure design. Like the design itself brings you wrong. Of course, you can also put the integrity check, but the question is, why add complexity when you can just simplify things and make the design more robust? So that was it for the first lab. Let's move on to the second lab, modifying serialized data types. So here's the link for the second lab. It's also here. I'm going to access it. So basically in this lab, the idea is the same as the previous one. There is a session cookie that is used as a serialized object. We need to modify that object to achieve some kind of privilege escalation or compromise in general. So let's get into the Chromium browser here and let's put it here. So we have this lab. Here I'm going to delete this. I'm going to delete here so that we have a clear history and so that we can just focus on this. So once again, I just want to log in to establish a session that I have the session cookie and I have my account page. Perfect. So here I have once again, the my account ID with winner. And here I have this object. Now, if we look at this, let's understand this session cookie. So what do we have here? Well, actually, I'm going to remove my webcam to make it more clear. So once again, we have URL decoding, base64 decoding. Now the object, however, is more complex, right? So let's take this, right? Let's take this and let's see how it works. So once again, we have O4 user, and then we have username, and then we have winner, and then we have access token with this particular value. So what could we modify in here? Well, I would say before we had to modify this admin. Now, since we don't have the admin anymore, we can try to modify the username maybe, or maybe the access token. This could be another path to victory. So if we check, let's check the proxy here within the login. So we say username winner, password Peter, and it says my account winner, and then it says this session ID. So I would say that, yeah, in this case, we can modify the administrator, basically, the username. So instead of writing winner, so let's say winner has 6 characters. We want to write administrator. Now, administrator has 13 characters, right? Which means that if we change administrator here, but we do not modify the length of administrator, something bad could happen. Let's actually just figure it out. Let's just send a request with burp to make sure maybe there is an error. You see, maybe we can trigger a stack trace, some kind of error, and this can help us. So let's modify the name with administrator. So let's do apply changes with the inspector, and let's just send a request. Look at this. I obtained internal server error. Now this thing is actually a good sign, because if the application was secure, maybe I would get a 401 error, like unauthorized. So kind of, you're not authorized to do this action. Instead, we obtain an internal server error. Now, if we render the error, it literally said, look, in the index.php, here we are linking a path, var www.index.php, there is this unserialized function that failed on line 4. So it failed because the data to be deserialized was probably badly formatted. And in this case, it's because we have this string administrator, which is long, as we said, at 13 bytes, but here we only have put 6. So what happens? Let me remember, it was 13 characters, yes. So what happens now if we put 13 characters? So we are changing the name fully to administrator. So let's apply the changes. Let's send this. So look at this. So look at this, it says uncode exception access token username equal xxxxx user access token equal, and then we have this thing, invalid access token for user administrator in. Okay, so now the error is no longer on the username, but it is on the access token. So what if, for example, in the access token we put S0, so a length of 0 bytes, an empty string? How would that work? We send it, and it still says invalid access token for user administrator. So what can we do here? What if we just remove this access token field? Does that work? It says, oh, let me remove this as well. Okay, it says it's still failing basically. So let's let's see. Username, administrator, access token, and then we have this us32. So here maybe we can try with some edge values, like let's say a string with 0 value like this. It's still oh yeah, because actually here I have just to put 1, so wait a second. Here I have to modify the length of this string. Now it's not 32 anymore, but it's 1. So it says still invalid access token for user administrator. Let's change, for example, the type to a number. We can do it with I. And here I'm just gonna put a number of like 1. So it still complains, what if the number is 0? Now with the number 0, this thing actually works. Now, at this point, let's ask ourselves, wait, why putting a zero integer value into access token works? And this actually has to do with the specific PHP version that is being used by this lab. Now, if we go into the lab and if we go into the int here, we say, note that PHP comparison behavior differs between versions. This lab assumes behavior consistent with PHP 7.x and earlier. Now, in this version of PHP, actually, something funny happens when you use the double equal and not the triple equal. So the basic idea is that the double equal will compare the value of the variables in a way that even if you have different types, you still can compare the different types. While the triple equals make sure that also the types of the variables are correct. That is, you have to have a string on the left and a string on the right. Now with the double equal, you can have a number on the left and a string on the right. Now the funny thing though is that this comparison is done in a specific way. And in this specific way, if you have a 0 on one side and a string on the other side, this is actually gonna match as true. So it's actually gonna pass, it's gonna be true. This is basically the idea with this exploit. This is why putting 0 in here worked. 0 is an integer, it is compared to a string, but in PHP, actually doing this in this particular version of PHP works. So basically in this lab, we had to edit the session cookie, and we have to change two things. First, we have to edit the username, not winner anymore, but administrator, and so we have to change the length as well. And also, we have to change the value of the token, access token. It is an integer with value 0. So that's the idea, basically. So once again, here we have found login. So here we can just do into admin, and then delete, and then username uguale Carlos, and this will solve the thing. This will solve the lab. If you do username, here I have it solved because I have edited correctly the file. So basically that's the idea. For the solution, we have to, this is the serialized data session, we have to change the administrator, and we have to change the access token to an integer of value 0. And so at the end of the day, we have this request which will allow us to authenticate as admin and delete the username Carlos. So this is a little bit more complex of an example because we have to make one non-trivial change. The change from winner to administrator, I would consider it somewhat trivial. The change with access token is not so trivial. So this highly depends on the kind of application that you're dealing with. However, the vulnerability is easy to spot because the vulnerability has all to do with the ability of the attacker to edit this serialized object, without being recognized by the server. So if the server does not understand if you are editing it or not, this is a vulnerability. Now, the way you actually exploit it, of course, requires you to understand how the backend specifically work, what kind of attributes does it use, what kind of specific value does it use. For example, access token of 0, okay, I'm gonna let you pass. So those kind of things can be more specific and they can be easier or harder to understand depending on the backend. But the general vulnerability is pretty simple to spot in this case. Just edit the serialized data object and see how the server responds. Finally, we arrive at the third lab, which is about Java deserialization. So we have seen Python deserialization with Pickle, PHP serialization and deserialization, and now we exploit Java deserialization. So this lab uses a serialization-based session mechanism and loads the Apache Commons collection library. Now, why is it useful that it tells us what kind of libraries it loads at runtime in the backend? We will see that. Although you don't have a source code access, you can still exploit this lab using pre-built gadget chains. To solve the lab, use a third-party tool to generate a malicious serialized object containing a remote code execution payload. Then pass this object into the website to delete the moral.txt file from Carlos' home directory. I mean, they really do not like Carlos, that is for sure. So once again, we can log in with the credentials, and here I have the URL to the lab itself. So let's just copy it here. So let's access the lab as usual. So let's wait for it to spawn. So basically, the idea in this case is that we know the backend runs Java, and we know the backend loads the Apache Commons collection. So this is the lab, and here I can just put into the let's see here what's going on. Chromium browser. Wait, where is the browser here? Intercept, open browser. I don't know why this was closed. I guess I closed it by mistake. So once again, let's just log in. We just need a session. This is the common pattern of all these labs. So here I have post login, and here I have my session. So this is a little bit bigger. So now if you consider this, here we have URL, we go into base64, but then from base64 onwards, burp does not really allow us to decode this. Now, if we decode this manually, right, for example, let's say, I'm gonna copy this value, I'm gonna write into a test.b64, and then I'm gonna say cat test b64 decode, base64 decode. So notice at this, look at this now, and I put it into test.bin. Now, if I analyze the bytes of this test.bin, look at this. It says lab active commons serializable, access to can user, access token, and a bunch of stuff like that. Username and other winner and other stuff like that. So in a way, this represents the same kind of object. However, this time it is serialized with Java, which means that the deserialization also happens with Java. That is, going from this sequence of bytes to the user object in Java also happens with Java. And so what's the idea? Well, the idea is that we can use a tool called YSOSerial. So the solution involves downloading this YSOSerial tool, and you can actually just check the page of the tool in here. So why this tool? It is a proof of concept tool for generating payloads that exploit unsafe Java object deserialization. So basically, this thing will serialize a bunch of objects that when deserialized will actually execute code. And the cool thing about this tool is that you can put any command and it's gonna create this serialized payload that when deserialized is actually gonna execute exactly that command. So it is a very useful tool to have. So I'm just gonna download it with wget from the URL, all these commands in the description, and then we're gonna use these generation commands. Now look at this. To actually generate the payload, here I have to add a bunch of add opens. Now, not all of them are needed. In this case, I'm not sure which are needed. So let's try without. I think without, maybe it's gonna complain. It's gonna complain because it's gonna say it does not export com.sun.org.apache.xalan.internal. So this one probably needed. So let's try to run like this. Okay. So basically, the idea is that these add opens allow you to export certain classes. And this thing is needed within the internal JVM in order to generate this malicious payload. So sometimes when you use YSOSerial, you can have like errors, but these errors are not related to the fact that you cannot do it. It's just that you have to explicitly put these options. Add opens with the name of specific classes. And you say all unnamed in all cases. So basically, that's the idea. Now, what do we generate? So when we use YSOSerial, basically, if we just use YSOSerial normally, here we can say java jar YSOSerial. Here is gonna pull out a bunch of names here. Payload, authors, dependencies. Now, these payloads means they are named based on the libraries they exploit. For example, common collection 1, 2, 3, 4, 5, 6, and 7. So it means If your application uses the common collection library, then one of these payloads might work. Because you have to consider that when you exploit a deserialization flow, a deserialization vulnerability, you are essentially loading a custom object into the memory of the process. So this is your browser, this is the server. Now the server has an image running with a bunch of objects, right? Instantiated in the memory. Object 1, object 2, object 3, and stuff like that. Now when you send a payload to be deserialized, the server will deserialize this payload in the context of this image. So if the payload deserialize asks for example, object 1 in order to trigger code execution, this can happen only if the server has object 1 in its own memory and therefore can trigger this memory execution. If it does not have, then it cannot, and so it's completely useless. So basically that's the idea. So how do we use this? Well, here we put name commons collection 4, which is a payload that works in this case. We put the command that we want to execute, and remember, we have to encode everything in base64. And then I put the -w0 to not have any spaces in the base64 encoding, so that we can immediately put it into the cookie. So let's put this command, and I'm gonna say out.txt. So now in out.txt, I have this big ass session cookie, and I can just use burp, basically, to put it here. Now when, and also I think I have to URL encode everything, otherwise it's gonna complain. So now it's URL encoded. So now when I send this, look at this. It's gonna say internal server error. It's gonna say constructor threw an exception, instantiate transformer. So it throw an exception, funnily enough. So what's up with this? Let's try maybe to have a different let's say, no, it says, okay, congratulations, you solved the lab. So even though it threw an exception, we actually solved the lab because we still managed to execute the code. We still managed to delete the file morale.txt from the Carlos home directory. So this is something that very often happens with deserialization vulnerabilities, is that the server might reply to you with a 500 message, with a 500 internal server error message. However, the exploit itself was still executed. It's just that at the end of the deserialization payload, the final object could not be constructed. However, we don't need to finally construct the object. We just need to trigger, trigger the remote code execution, trigger the code execution which happens during instantiation of the object. You can imagine this as a computation. You start to read the bytes and then you have the final object, right? Now, if the code execution happens here, and here we get an error, we don't really care, because during the instantiation of the object, at some point we have executed code and we already have our impact. So here I have to remove my webcam, but basically on the left we have reading of the bytes, on the right we have instantiation of the object, here we have the RC, and here we have an error. We don't care for the error because we already executed our code and this is what we want ultimately. So basically that's the idea, and you can, use YSOSerial with other payloads as well. I suggest you to script it out. I have a script in the BSCP repository in my private Patreon for those of you interested. So basically that's the idea. And so this is it for this video. In this video we covered insecure deserialization. We showed 3 labs from the Portstrigger Web Academy, but the basic idea remains the same. We are able to modify the serialized expression of an object. We can modify it, we can add our own fields, we can modify the value of existing attributes, and if the server does not check the integrity of the serialized bytes, then we can introduce malicious payloads, and this hopefully can allow us to obtain remote code execution. So this is it for this vulnerability, and to the next vulnerability. Thank you very much, and if you want to support me, there's a Patreon. To the next video.